Hi everyone, this is Mr. Lee. In this video, we are going to go over how to find the acceleration through gravity, or G, for different planets. All right, let's begin. So on your screen, you should see the formula for the universal force of gravity. And with this, let's just do a quick little sketch. So what I'm going to do is I'm going to draw the Earth here. Okay. Notice I'm drawing the Earth as a dotted line. Okay, because that's the actual Earth. But it's important for us that we represent anything that is spherical or a planet as just a point particle. Okay, so that's the idea. Is if we were to get the Earth and we're to just smush it to a tiny little point, that point will be right there. Okay, and so we are going to represent the mass of the Earth with a capital M. Now, let's say we have you on the Earth, and we're going to represent you as a tiny little dot, because compared to the Earth, that's probably what you look like, just a tiny little dot. And we'll represent that as a lowercase m. All right, so taking a look at this, we know that when you are on the surface of the Earth, there is a gravitational force pulling you towards the center of the Earth, and we just call that F of G. Now, according to this formula, okay, we can actually see how we get Fg is equal to mg. So, quick little recap here. The idea of weight, okay, weight is how hard or how much a planet or other objects pull on you. So, weight is equal to F of lowercase g, which is equal to mg. We should be able to go from this formula up here to this formula down here with this illustration. So let's go on that journey. All right. Now, if we take a look at this formula up here, we can see that the capital M is the mass of the planet, and this lowercase m is your mass, and this r is the distance between the planet, the core of the planet, to you. So this is r. All right. But if we substitute that formula in for net force formula, so we have F is equal to ma, okay, and we know that the only force acting on you is F of g. So this is F of g here. This is the gravitational force, because we're looking at specific point models. So I just want to make that distinction, because we're looking at the Earth and you, we're going to use the capital G version, versus if we were to look at you on the surface here, right? Because all of this down here is the Earth, right? We don't view the Earth as a point particle in this case, right? This is all the Earth. And so for this instance, we can use the lowercase g version. Okay, but what we're trying to do is we're trying to see how this lowercase g formula gets us to this capital G version right there. All right, so because we're looking at the Earth and you, okay, we're looking at the capital G version, and so we have this M. So this is the system, right? So the force of gravity is acting on you. So this is lowercase m, and then we have this A. Now, I'm going to put the A in parentheses, because that's what we're trying to find. Okay, the acceleration due to gravity. We know the acceleration due to gravity for here, us on Earth, is g. And so now the question is, how can we link F of capital G to F of lowercase g? Okay, so on the other side, I'm going to substitute in the formula for F of capital G. So we have G, capital M, which is the Earth, lowercase m, which is you, all divided by r squared. Okay, and all this is equal to mg. So I'm just going to rewrite that below it so it looks the same line. There we go. Okay, now if we do a little bit of algebraic manipulation, we see that a couple of variables cancel out. So that m, which is the m of u, and that m is, the m of u, because they're the same variable, they cancel out. So that gives us g is equal to g, capital M, all over r squared. Now this is unique because this formula right here, it tells us the accelerational, or the acceleration due to gravity for any single planet. Now for us here on Earth, this is 10 meters per second. Okay, but the idea is we could use this formula right here for any other planet. So I'm going to put it right there next to it. This isn't on the official formula sheet. I'm going to put the term planet right there, because if you know the mass of, let's say, Mars, we could plug in the mass of Mars, and here this is the radius of the planet. Okay, if you know those two values, you can see the acceleration due to gravity for that planet. Now, another way of coining this term, instead of g of acceleration due to gravity, g is also known as the gravitational field strength. Okay, so the idea is if you have, let's say, the Earth here, right? So here we have the Earth. We view the gravitational field pointing downwards, meaning that if you were to put a object such as, I don't know, let's say we have a green ball, okay, that green ball, because it's within this gravitational field G, the gravitational field on that ball will make sure that it gets pulled down, and therefore all objects fall towards the center of the Earth. So G is the gravitational field. In kinematics, we call that the acceleration due to gravity, but it's the same idea, and the formula for that is right there, capital G, m of planet over r squared of the planet. Okay, and so whenever you're trying to find the weight of something else on a different planet, okay, it is still f of g is equal to mg, but the idea is that this g is the g of the new planet instead of, let's say, 10. All right, and that'll tell you the weight of you on any other planet. All right, I'll see you later. Bye-bye.